first problem is to add a node to the top of the list. So so you're giving the head of a list. Your job is just simply to add and the value. Put the value to the beginning of the list. So if you're giving a head that points to null and the value of 5, what you should have is you're giving a head with an actual list in it. 5 should be in this case 5 would be the only thing here, or inside this case 5 would be the first thing inside of the list. So to give you a better understanding of it, you can either be given an empty list. In this case, you place 5 there, or you can be giving this where there's already multiple nodes there. Let's call this node 1, node 2, and then so we know that it's sequential. And that's that. Alright, so let's begin solving this problem. But before we write our function, we actually need to define our linked list. Let's define what it looks like. So let's call it, say, class single linked list. We can say that linked list. And then we have a linked list has a node. The node has a data and he has a pointer. If you remember from the intro, that a node has two things, a data and it points to the address of the next node. So we need to define that here. So data is going to be anything. It doesn't matter. You know what? Let's do it right. It can be a string, a boolean, or it can be a number for now. And then the next, we call it next, it can be null or it can be a list. So the next is the pointer. So this can be null, as in this case it's null, or it's a list, as in this is a list. So that's what I'm saying here. And then we'll have a constructor. Now in our constructor we need to have, we can pass in data, but it's optional, not all the time. And our data is of type this. You know what? Let's define a type. Let's say no type. No type. There we go. And then we can do this. So our data is of no type. And we can also pass in next, but that's optional as well. And our next is here. There we go. You can say pointer type. Pointer type. Again, this is all TypeScript stuff, honestly. Pointer type. There we go. If you're not using TypeScript, you don't need to put this here. You can still follow along. You don't need to put public. You don't need to put no types, any of that. So you can still follow along if you're not using TypeScript. And then we say this dot data equals data. What about if data is undefined? If data is undefined, it's a problem. It's the value would be undefined, and we don't want that. So we can say if it's undefined, if the data is defined, set it to data. Else make it 0. So we initialize our data with 0. Now, and then the same thing. This dot next equals next. And if next is undefined, same thing. Set it to null. So we've initialized our list. So every single thing, so it will never be empty basically. So there'll always be something here, based on the definition I just did. So there'll always be a 0 here, basically. There'll always be a 0 there. Based on this definition I just did, there'll always be a 0 because we just initialize it. If it's undefined, set it to 0. Else, and then the next would be null. So that's exactly what this is, meaning that the thing that it's pointing to would be null. That's what we just defined with our list here. Now in JavaScript, instead of doing all of this, you can also do this. It means the same thing. There we go. So this is our list. Now the next thing is we want to add the node to the top. That's what we want to do now. We want to add the node to the beginning. So now this, the first thing is we're gonna passing a head. Remember that. So no, the head is a pointer type, and then we're gonna pass in a value. The value is a node type. So let's define our new node. Our new node there we go. Passing our data. So this is our new node. This is the 5 right here. This 5 that we're gonna add here, that we're gonna add into the node, that's what this is. So we've defined it. So we have to ask a simple question. We'll say if the head that you pass us, if it's null, now instead of saying if it's null, I can just say this. If it doesn't exist, it's undefined. But I prefer to say if it's null, because it shows everything easier. If it's null, then I'm gonna say head equals new node, and then I'm gonna return the head. If it's not null, that's fine. If it's not null, then I'm gonna create a copy of the head. When I say I'm gonna create a copy of the head, what does that mean? So you know how we have the head already. That's doing all of this work here. I'm gonna make another copy of the head. I'm gonna call it PT. That's what I just did here. So it's gonna do the same thing the head is doing. Let's just move this. It's gonna point to this. So now we have this. We have two things here. That's exactly what I just did here. I made a copy of the head. Now I'm gonna say to myself that the head equals new node. So now the head equals the 5 basically that we just made, and then the head the new node's next. The new node's next value equals our copy, and then we return the head. So that's how you add a node to the top. So what am I saying here? I made a copy of the head. That's what I did here. Then I said the head equals a new node. When I say the head equals a new node, what I'm saying is I created the node 5 right here, and I removed this head from here to point to this 5. This line right here, line 27, is this picture. That's what I moved the head away from the list, and I pointed it to 5, the new node. And then this line, I said the new node's next equals pointer. So the next thing this guy is pointing to equals what? What does it equal? Equals the pointer, the copy that I made. And what is the copy that I made? The copy that I made is pointing to this. So I said the new thing this is pointing to equals this. Now I put the 5 in front. That's exactly what this line does. And I return the head. And you can see the head is still pointing to 5, node 1, node 2, and null. That's exactly what happens here. So let's test this out. So we're going to test it out. We need to create our list. So we can say head is new linked list. Doesn't have to be anything. And now we are adding a node to the top. What node do we want to add? 5. Oh, we need to pass in the head as well. So this is the head that we're passing in, that's why. Okay, so let's print this out. We need to print it out. Oh, we don't have a print function. It's easy to write. Let's do that. The next assignment is to have a print function. So print node, print list, let's call it. So the print list is just gonna take in a head. That's all it's gonna take in, and it's gonna print it. That's all it does. Print to the console the head. Done. So let's print that out. has the head into it. Let's print it out to the console. Let's clear this. Since we're using TypeScript, let's compile our work. Now let's execute it. As you can see right here. So we have our list. We have 5 because it was empty at first. No, it wasn't empty. We initialized with 0. I'm sorry. So our list had 0 before in it because we initialized it with 0 over here. What if it's undefined? And then we added 5 there. If you don't want to initialize with 0, we can just here when we are creating the constructor, you can pass in the 5, and that would be our first node technically. But we initialize it with 0, and then we added 5. You can see 5 goes to the top. I'm going to add another one. If I add another one, let's add hello. So hello should be in front of the 5. It should be in front of the 5. So let's try that. Let's compile. And then let's execute. You see? Here's our list. Hello is in front of the 5 because we're adding it to the top of the list each time. All right. Hopefully that helps.